Hi, I'm Shirley. It's my pleasure to share with you a consulting project for Curacel Systems in Insight. That is automated flagging of false medical insurance claims. False claim is a universal problem for all insurance companies. In the data we get from Curacel, 5% of total claims are false claim, adds up to $0.8 million. And to combat false claim, the company spent over $1.17 million to process those claims. And this value can be as big as 20 billion per year for the USA. Processing claim also takes a long time, at average of over 40 days, and cost of premium to go higher. Therefore, if we could find a way to automate claim processing, would be a great benefit for both company and customers. To find a solution, I queried the company's database, and I found 9 tables with over 1 million rows. Further understand the content of the tables, as well as excluding those abnormal values and cleaning the data, I found 4 tables with useful information, and I joined all those information to get the final data set. In order to find the most relevant features to build the model, we first need to see whether those features has a distinct pattern between the false claim and the legal claims. For example, I first explored the distribution pattern between the two types of claims. I used the cumulative probability curve to accumulate the difference. As you can see, the bigger, the more separated of these two curves, the bigger the difference would be between the two types of claims. And time series view also indicate monthly information might be useful. I further explored the relationship between features. For example, in this heat map correlation of two categorical features, I included the probability of the difference of each value pairs that present in two types of claims in color, as from 100% of legal claim, which is blue, to 100% of false claim, which is red. As we can see, a lot of red dots that are distinctive, indicating there are specific value pairs that tend to associate with higher probability of false claim. Therefore, we found 11 features. First is patient with over 10K unique values, and I engineered 2 features for that: provider, diagnosis, and claim amount, which comply with gamma distribution, and care, which have 5 features, and also policy, insurance policy. The outcome would be either the legal claims, which is negative plus, or false claim, which is flagged as positive. As we can see, the challenge of the data that is highly imbalanced, huge dimension of categorical data, and tight correlation of features. Therefore, I choose XGBoost and LightGBM to handle those 3 aspects, as well as use naive Bayes as a comparison, which can only handle the 2 aspects. I used testing data to evaluate the model, and I choose Rockout curve as indicator of general model learning capability. As we can see, naive Bayes is just a little bit better than the dummy model, which is the dashed line, while XGBoost and LightGBM performs similarly well. Further tuning the table with parameters, and as well as upsampling the training data to balance the data sets, I get the final best model with the indicated positive and negative rates in this confusion matrix. I further use this model to explore the importance of feature. For example, if without enrollee feature, all the scores will drop and lead to a loss over 100K, while without diagnosis feature, the loss will be about 50K. We can further tune the model to favor sensitivity at the cost of specificity or vice versa. But should we do that? We can use this balance to calculate. For example, in our case, 1% increase in true positive rate will save the company $8,000, which is 9.4 times than the cost of 1% increase in false positive rate. And eventually, we tuned the model to add 25 to the positive class. Eventually, I provided a proof of concept model to potentially save the company over $80K in this dataset, and we shortened the claim processing time from more than 40 days to instant. There are still some room for us to improve the model if we can have more data. And the detail of this story could be further found in my Medium blog post. I'm a PhD in neuroscience with over 10 years of quantitative research experience. I'm well-versed in experimental design and statistics. And I handled various of data types across different disciplines, and also served 2 biotech companies that I gave my business sense. I'm super enthusiastic about data science, so I kept learning data science for the past 5 years, and my other project can be found in the GitHub portfolio. I believe my research experience, versatile background, quantitative mindset, and my business sense would add value to the company for problem solving. Thank you very much.